Okay, now we are about to program our last operation, that is the backwork. As you can see here, I did turn purposely the part around because this is how you represent the part when you are doing the backwork. You just turn it around. As you can see, my numbers are upside down too since I turned it around. But anyway, we will be turning this diameter 6 on a 3 millimeter depth, and we will do a chamfer as we enter, and we will also do a chamfer as we exit the face turning into the drill diameter 4. So let's do it. We will start by checking the tool geometry, and to keep it within the Tornos TB-Deco convention, since it's longitudinal, we will use a tool name 4621. So in my variables here, I can see in variable 3016, number of the first backward tool geometry. So I have a backward, so I will put a number, and I have by default 4601, which is normally used for transversal or outside turning tool. I want to change it to 4621 0. So it's going to be changing automatically also once I generate the tool call that we see here in the backwork, right? So now it's 4601. Once I generate, it will be 4621 automatically, and that's good. Now I want to quickly look at the speed. We did the cutoff at 3000, and let's say for now I want to do my backwork at minus 4000 RPM. We can always optimize that later. We will do that later. A little advice, by the way, since we are talking about the speed and M3 and 4 direction, since the backwork spindle will be turning at M4 direction, it is good in order to avoid having to invert direction of counter spindle and then losing time. It is good to use left-handed tools for drills and also for a turning tool, so we can possibly keep always in the same direction of rotation, that is M4. It saves a lot of time and stress on the backwork and everything. So this is a quick advice. And this is what we will do in this example. We will stay in the M4 direction with our counter spindle. Now let's also quickly look at the geometry of the tool 4621. 4621 is a drill, so we will change it to an inside turning tool. So I come back here, and then here I will type 4621 0. And in my turning tool, I will choose an inside turning tool. And then here I want not an infeed inside, I want a turning tool front inside. Okay. Already exists. Do you want to change? I want to change. Yes. So here I put my standard backwork geometry for that type of tool, 200, and here minus 20. And let's say we will have a corner radius of 0.1, and then the quadrant will be very easily found, quadrant 2. Okay? Okay, I can save. So now I can go back directly to my programming of the operation. So this is the tool call, and I open this operation, and I want to change the icon. It's going to be an inside turning. And then here I will say back work inside diameter 6 millimeter. Okay. So I will do my approach. You remember the approach has been already stated into the variable, so we don't have to do anything as far as the primary approach for the tool. So now I call it to G1, G100, Z 46 equal 1. I come close to my part, and then x 46 equal 7. Then I will, in the next move, call my radius compensation. This time I will call it on the left side of my profile. 41 x 6.8 and z 0.2, and then I can use a relatively big field since I'm not cutting material yet. And then I start to do my chamfer. Minus 0.2, and then I come to my diameter 6 in x, and now I can use a smaller feed since I am cutting material and I want to have a nice entry chamfer. Then I will go down to my depth of 3 millimeter for this diameter 6. I can increase a little bit my feed here. And then I will go down the face, x 4.3. I increase a little bit my feed. And then G1, Z minus 3.4. And then I will give it the angle. So I do it with Q45 and F 0.05. So in this case, I use a possibility given by TBDeco, not to give one of the two arrival points. You just give, for example, I give my arrival point at Z and I state what angle, and then TBDeco will calculate automatically the arrival point in X, which is sometimes very useful. And then I exit in rapid and I cancel my radius compensation. Okay, it is done for the inside turning tool in my backwork. Now I validate. Let's generate to see what's the result. It's looking good. If I look at the profile, this is what I want. Rapid approach. I take my radius compensation. I do my chamfer, diameter 6 on 3 millimeter deep. Face, exit chamfer, and I exit. So this looks good. Let's not forget to save. And then I can see here my cycle time is of 7.1 second, 7,190 milliseconds, and 8.3 parts per minute. So we will try to optimize this, and we will do that in the next video. We'll go through different small tips and tricks and see how we can optimize our production and make it go faster without having to increase our feeds and things like that. So we'll try to see where we can gain time on the unproductive moves. And this will be the topic of the next video. That's all for now. I hope this has been useful for you, and see you in the next video.